Okay, so for this video, we will be discussing the October-November 2022 paper, Statistics and Probability 1, paper 5.3. So let's start with question number 1. We are having the 50 values of variable x that are summarized by these values. We are having summation of x minus 20 and also summation of x squared. So they want us to find the variance of these 50 values. All right, so first of all, before we can find out the variance for the 50 values, there are a few formula that is related to this question. So for the first one, we are having the mean formula, where it can be summation of x minus 20 divided by n. So the n for this case is 50, right? And then plus 20. All right. Then what is the formula for variance that we have here? So the variance formula that we have, it can be summation of x squared divided by n, then minus summation of x divided by n squared, or some of us will write as mean square. Right, so this is the formula for variance, and this is the formula for the mean, right, using the coding method. So from here, according to what we have in the question, we can apply this first formula to calculate the mean first. So if I want to get the mean, I will have mean equals to 35 divided by 50, then plus 20, and I get 20.7 for the mean. All right, then to calculate the variance, I will apply the second formula here, because according to the information given here, we are having the summation of x squared. So summation of x squared would be 25036 divided by the n, which is 50, and minus the mean square. So I'm having 20.7 square. Then try to calculate this value, I will get 72.23, or if you want, you can rephrase it or simplify it, become the 3 significant figure answer, where it should be 72.2. Right, so basically this is the formula involved, okay, that for us to calculate the mean first before we can continue to get a variance for this kind of question. Okay, so question number 2. In a large college, there are 32% of the students have blue eyes, and then there's a random sample of 80 students is chosen. Use an approximation to find the probability that fewer than 20 of these students have blue eyes. Okay, so the very important keyword here is approximation. So according to AS syllabus in Statistics 1, the only possible approximation so far, right, is only from binomial to normal. That means originally I'm having a binomial distribution. So the x will be the number of students who have blue eyes. Okay, so binomial distribution, I'm looking for the n value. Okay, so the sample with 80 students, so the 80 will be the n, and then the p is the proportion. Okay, so proportion of student having blue eye is 32%, therefore I will put 0.32 as a p, value p, in my binomial distribution, and then I will change it become normal distribution. Okay, so since the question already mentioned that we have to use approximation, so from binomial we'll change it become normal, but actually when you want to apply approximation, right, change from binomial to normal, basically what we need to do is that we need to have the criteria where n is greater equals to 30, np is greater than 5, and also nq is also greater than 5. Okay, if you double check all the criteria here, you realize that actually when we change it, it fulfill the criteria to change binomial become normal, right? So to get the normal value, the parameter in the normal distribution, I want to have the mean for the normal, okay, for the first value. So the mean, how to get the mean from binomial distribution? I'm using 80 multiplied with 0.32, and I will get 25.6. Then to get the variance, it will be NPQ, where you will get 17.408. Okay, so just to recall, this is the n and this is the p. To get the mean in the parameter of normal distribution, it is n times p, which is the mu. And then to get the variance, it should be NPQ from the binomial distribution. Okay, so after we decide and we get all the mean and variance already, we can start to calculate the probability. We want to have the probability that number of students fewer than 20. So fewer than 20 means that we are having less than 20. Okay, to calculate the value for x less than 20, from binomial become normal, we have to apply continuity correction. The reason is because for binomial distribution, it is belongs to discrete random variable, and for normal distribution, it is belongs to continuous random variable. All right, and discrete random variable, they are gap. Okay, between the value for x and continuous, they are smooth. No gap between the value for x. Therefore, you have to do some simple adjustment. So the simple adjustment, you call them as continuity correction. Okay, so for the continuity correction, x smaller than 20, okay, it includes 19, right? X smaller equals to 19. Therefore, the continuity correction should be 19.5. Okay, then try to change it become z. Right? So to try to change it become z, and then to change it become z or standardize it, we need to minus the mean, divide by standard deviation. So this is my value of x. I need to minus the mean, where minus 25.6 divided by standard deviation. So I have to divide the value by using square root of 17.408. Okay, get the value for z correct to 3 decimal places, and I'll have negative 1.462. This particular area is equals to greater than 1.462, and I have to take 1 minus the value that I get from the normal table to get the answer. So I'm looking for 1 minus z smaller 1.462. So we go to the normal table, 1.462. This is 1.4, 6 is this value, and 2 is this one. So that means I have to add 3 to the last digit of 9279. Okay, so if I add the 3 to the last digit of 9279, I will get 0.9282. And from here, we will get the answer, which is 0.0718. This is already in 3 significant figure. Alright, so this is how we answer question. Okay, so now we come to question number 3. Okay, so we are given the data with time taken and also the cumulative frequency. And according to the sign that we can see here, right, on the first row of the table, basically it is the upper class boundary, and we can straight away plot the upper class boundary with the cumulative frequency. Okay, so before we start plotting the points, right, our cumulative frequency should start from 0, where the first class is t with smaller equals to 0, and the value of the cumulative frequency should be 0. So we should plug in this value here so that our graph can start from the 0, 0, right? Okay, so to sketch the diagram, I will make the graph smaller so that you can see clearer what we draw. Okay, so first of all, of course, I have to decide the ratio for the x and also the y axis. Okay, so for me, what am I going to do is I will try to start the x-axis from 0 until 60, right? Because you can see the largest value for t is 60. And then for the y-axis, the largest value is 250. So according to the graph paper provided, I will start the graph here. Okay, and then for the y-axis, try to sketch it out first. Okay, so the y-axis will be cumulative frequency. For the x-axis here will be the time in minutes, right? So we call it as t minutes. Okay, so we try to plot the point. Okay, so for the scale of the x-axis, I want to label it as 10, 20, then 30, 40, 50, and 60, until 60 lah. Then for the y-axis, I want to have it until 250, so I think it would be better if we put it like this: 50, 100, 150, 200, and also 250. Okay, then we can start plotting the point here. Okay, where what do we have is, you can refer to the table, alright? by the pair. So the first value is t smaller equals to 0. The cumulative frequency is 0. So if I try to sketch it, I will plot 0 and 0. Okay, then the second pair of value will be t smaller equals to 20, and then the cumulative frequency is 32. So at the 20 here, I'll try to measure 32 and plot it. Okay, so for information, right, because our scale is not very small, therefore we can roughly plot it. So 32, to me, I think it will be somewhere here. Okay, next value, t 30, then the cumulative frequency is 66. So 66 will be somewhere here. Okay, so I just plot it according to what I understand and what I see here. Then 35 is 112. Okay, 40 is 178. Okay, 50 is 228. Okay, so 228 will be somewhere here. And then 250 for 260. Okay, so after I plot all the points already, I try to connect them with a smooth curve. Okay, so please ensure that your cumulative frequency graph should start from the 0, 0. Okay, so try to connect all the points by using the smooth curve if possible. Okay, so this is my cumulative frequency graph. Okay, for this set of data, make sure that you label the x and y axis clearly by using the suitable ratio for the x and also the y axis. Okay, so this is the first part. Then let's proceed to part number B. Okay, so for part B, they want us to use your graph to estimate the 60th percentage of the data. Okay, so 60th percentage of data, I need to know it is at which location of my data. So I'm having 250 frequency in total, right? Okay, 250 frequency in total. The members are then the 60th member will be, I need to multiply with 60 and divide it by 100, and I will get 150. So that means I need to read the value from roughly 150 cumulative frequency to read the value for the t. Okay, so where is 150? It will be here, and then you can try to draw a horizontal line. Okay, start from 150 and to touch the cumulative frequency curve that you sketched just now, try to read the value from the x-axis. Okay, so from here, if I try to read the value, right, the value that I get is more or less 37. Okay, so in your solution here, you can just try to write the t is equals to 37 minutes. Okay, so basically this is how we calculate we get the value of t from the cumulative frequency curve that we draw just now. Alright, and next one for part number C. Okay, so for part C, what they want is they actually want us to calculate. It is given that an estimate for the mean time taken to complete the challenge by the 250 members is 34.4 minutes. So we are given the mean time, and they want us to calculate the standard deviation, okay, for these 250 members. Right, so before we calculate the standard deviation, I might need to convert my data into class so that I can get the midpoint, which is the x, and also I need to convert my graph from cumulative frequency become frequency, which is the f. Okay, so for the class boundary that I get from the table, right? So I will just copy the value that given in the table. So this one start from 0 until 20, right? So the first class that I have, I will put it as 0 until 20. So according to the second class, what do I have here will be from 20 until 30. So we are just using all the value given in the upper class boundary. So 20 to 30. Therefore, my value here will be 20 to 30. So we continued for the rest. Okay, so the next class will be 30 to 35, then 35 to 40. Okay, so 40 to 50, and last class is 50 to 60. Okay, so to get the midpoint, which is the x, basically we need to take lower class boundary plus upper class boundary divided by 2. So for this case here, we are taking 0 plus 20 divided by 2 and I get a 10. Okay, 20 plus 30 divided by 2 and I get 25. Okay, so please make sure that you list out all the midpoint in your calculation, as all the midpoint will be given marks. Okay, given method marks. Okay, then for the frequency part, you need to get it from the cumulative frequency. So the first value for the cumulative frequency is 32, right? So the first class frequency will be 32. To get the frequency for the second class, what we need to do is we take the second cumulative frequency minus the first one. So 66 minus 32, I'll get the frequency for the second class, which is 34. The same thing happened for the frequency for the next class. I take 112 minus the 66. If I take 112 minus 66, then I will have 46. So I repeat the process until I get all the frequency for every single classes here. Okay, so after I get all the midpoint and also the frequency, I can try to get the summation of f multiplied with x squared. That means I take the frequency, multiply with the value of x, which is a midpoint, and I square the midpoint first. Okay, so square the midpoint, then multiply with the frequency. Alright, so if you try to figure out the summation of fx squared, basically it will be something like this. Okay, then try to use the calculator and get the summation for this fx squared. Okay, if you didn't do any careless mistake by right, this is the value that you should get at 333 and 650. Okay, after I get the value for summation of x squared, then I can continue to get the standard deviation value. To get the standard deviation value, right, the formula is what? The formula will be the square root of summation fx squared divided by the summation of f, then minus the mean square. Okay, so I will just plug in the values that I get here into the formula to get the answer for standard deviation. So summation of fx squared will be 333,650 divided by the summation of f, which is 250. Okay, then minus the mean. The mean is given in the question just now, which is 34.4. So 34.4 and I square it. Again, if you didn't do any careless mistake, by right you should get the square root of 151.24. Then again, continue to simplify your answer. Correct to 3 significant figure, it should be 12.3. Okay, so this is the process how we actually get the standard deviation value from the data given here, where it only provides us the upper class boundary and also the cumulative frequency. Question number 4. We have 3 fair 4-sided spinners, and then each side label 1, 2, 3, 4. The spinners are spun at the same time, and the number on the side on which the spinner lands is recorded. Okay, the random variable x denotes the highest number recorded. So x is the higher numbers that we get among the 3 fair spinners that we spin. Okay, so first they want us to show that the value for x equals to 2, the probability for x equals to 2 is actually 7 over 64. Okay, so before we start calculating the probability, maybe you can try to list out. We can try to list out the possible cases that we will get x equals to 2. Since x is the highest number recorded, right? That means that if let's say I want to have x equals to 2, either we have the case where there are 2 spinners with the score 1 and 1 spinner with score 2. So the highest value is 2, right? So for this case, x is equals to 2. So for this one, I might have 1, 1, 2, I might have 1, 2, 1, I also have 2, 1, 1. All the cases are having x equals to 2 for 1, 1, 2, 1, 2, 1, and 1, 1, 2, 2, 1, 1. Therefore, I just make a note that this case I need to multiply with 3 when we calculate the probability for this particular case, right? Then what is the other possible result that I can have? X equals to 2. So maybe I'm having 1, 2, 2. When my 3 spinner show the score 1, 2, 2, that means my highest number is 2 as well, right? So x also equals to 2. So when I'm having 1, 2, 2, I can have also 2, 1, 2. I can have 2, 2, 1. So there are 3 cases also, 3 times, right? If I want to calculate the probability for this particular result. And another possible result is I might get 2, 2, 2 lah. So when I have 2, 2, 2 here, okay, all the 3 spinners show the score 2. The highest number is x is equals to 2. And for this one, there's no other cases. 2, 2, 2 is only one case, so multiply with 1 only. So to calculate the probability for all this, I will list out the steps here. So for the probability of x equals to 2, I need to calculate the probability for 1, 1, 2 multiplied with 3. I need to calculate the probability for 1, 2, 2 multiplied with 3, and also the probability of getting 2, 2, 2. Okay, so for every spinner here, there are fair spinners. So to get the score 1, it will be 1 over 4. For the second spinner, if I want to get the score also equals to 1, it will be 1 over 4 as well. To get the 2, it will be 1 over 4. Okay, because it is the fair four-sided spinners, right? Okay, so for each possible score that we have for every single spinner here, it will be 1 over 4, and I multiply with 3. Same thing happened for the second case here, 1 over 4, 1 over 4, 1 over 4, multiply with 3. And after that, for 2, 2, 2, also 1 over 4, multiply with 1 over 4, multiply with 1 over 4. So if I simplify all the answer here, by right, we should get 7 over 64. Right, so this is how we get the answer for this part A. And now we can proceed to part number B. For part number B, they want us to complete the distribution table for x. So from here, they show us very clearly that we are having x equals to 1, x equals to 2, 3, and 4. And the probability for 2 and 3 is given. So let us start with the probability that I will get x equals to 1 first. So for x equals to 1, right, where 1 is the highest score, I have only one case where all the 3 spinners show the score 1. So 1, 1, 1. Okay, first spinner to get the 1 for the score 1. For the first spinner, it will be 1 over 4. Second spinner also 1 over 4. Third one also 1 over 4. So if I simplify the value, it will be 1 over 64. Okay, so this is the answer for the probability of x equals to 1. So you can put it in here, 1 over 64. And to calculate the value for x equals to 4, okay, there are many ways that we can do it. So the first method is you can either take 1 minus all the other probability that we get in the table. But of course, you have to ensure that the value that you get for the x equals to 1 should be a correct probability, okay, so that your final answer is correct, right? So if I would take 1 minus 1 over 64 minus 7 over 64 minus 19 over 64, and by right, the answer should be 37 over 64. This is the first method. Okay, but of course, if you want to use this method, basically, you have to ensure and you have to make sure or very sure that the value that you get for the probability of x equals to 1 must be a correct value. If this value is wrong, definitely your answer for this part also will be wrong. Okay, so if let's say you are not so confident about your answer in x equals to 1, then you have another option where you can try to think, okay, what are the possible steps that you can use to get the highest score, which is x equals to 4. If we are looking for highest 4 equals to 4, right, there are many possible cases. Okay, so the easier way will be we can try to consider if I take 1 minus the probability that no 4 shown in all the spinner. Because if let's say there's no 4 shown in all the spinner, right, no matter what is the score show, as long as it is not a 4, then the highest number is not a 4. Correct or not? So I will take 1 minus the probability of not showing any 4. Okay, so what is the probability of not showing 4? That means for first spinner not showing 4, it will be 3 over 4 lah, because you can have the score either 1, either 2, or either 3, but not 4 lah. Okay, so 3 over 4. Second spinner not showing 4, also 3 over 4. The third spinner not showing 4, also 3 over 4. So you can simplify this by taking 1 minus all the value here. Alright, then you should also get 37 over 64. So for this particular probability, you can choose and see which method you understand better. Alright, so this is how we answer the question number 2, part B. Question number 4, part B. Alright. So I will fill in the value here, which is 37 over 64. Alright, then we can proceed to part C for this question. For part C, they are saying that in another occasion, one of the 4 fair-sided spinners is spun repeatedly until a tree is obtained. So highlight this phrase of the sentence here. When we are having this kind of sentence, right, or structure of the question, you can see that repeatedly until something happened. Okay, to me, I think the keyword would be until something happened. The word is until. So this phrase of question generally tell us that it belongs to geometric distribution. Okay, so when you're having the geometric distribution, okay, so we need to know what is the P. So the P will be 3. The probability or the proportion of 3 is obtained, so which is 1 over 4 here. Okay, so your P is the probability that 3 is obtained in a single throw, and therefore it is 1 over 4. Okay, and then for this occasion, they only throw one of the 4-sided spinners only. They are not throwing all the 3, but they only throw one of them. So the random variable y is the number of spins required to obtain the 3. So y is the number of spins required, and y is geometric distributed with the p equals to 1 over 4. Okay, calculate the probability for y equals to 6. Okay, so for any geometric distribution with the probability p, right, with the parameter p, generally if you want to calculate the probability for y equals to r, it will be equals to q power r minus 1, and then after that you get a p here. Okay, so same thing happened for our question here. For the probability of y equals to 6, right? So what is the value for y equals to 6? Okay, since I already know that my p is 1 over 4, so the first 5 times of the throw or the spin, I didn't get 3. So it will be 3 over 4 power 5. And then only at the 6th time, you get this number 3 that you want, which is the probability of 1 over 4. And when you simplify this question, you will get 0.593, 0.0593, then 26171. It should be a long value, and we need to cut it short into 3 significant figures, where it should be equals to 0.0593. Okay, so this formula I think is quite straightforward to apply. Okay, so please look at the keyword until something happened or until something is obtained. So this gives us the idea that it belongs to geometric distribution. Alright, and now proceed to question number 4. So for question number 4, they want us to find the probability that y greater than 4. Okay, again, for any geometric distribution, right, with the parameter p, we have a general formula where y smaller equals to r. Okay, so please take note there must be a smaller equal sign here. Okay, the general formula will be 1 minus q power r. Okay, this is a general formula for the geometric progression, geometric distribution. For this case, they want us to calculate the probability for y greater than 4. We can try to rephrase our question into this pattern. So when I'm having y greater than 4, it can be written as 1 minus probability of y smaller equals to 4, right? Okay, so for greater than 4 means that they want to start from 5 lah. Y equals to 5, y equals to 6, 7, 8, and so on until infinity. So instead of this, I will take 1 minus y equals to 0, 1, 2, 3, 4. And please take note on this part here. Generally, we are having y smaller than 4, and you can see that your r is a 4 now in the formula. Okay, so to get the answer, you can take 1 minus q power r. So q is 3 over 4, power r will be power 4. Okay, so try to simplify your answer from here. 1 minus 1 becomes 0, and then we are having 3 over 4 power 4. Okay, change it become a fraction, you will get 81 over 256, or if you want to correct it to 3 significant figure, it will be 0.316. Okay, so this is how we answer question number. Okay, question number 5. We have company A produce bags of sugar. Then an inspector finds that on average, right, 10% of the bags are underweight. We are having 10 of the bags are chosen at random. Find the probability that fewer than 3 of these bags are underweight. Okay, so for this question, right, we can see a very the structure here, where we are having a bigger number of bags, which is 10, and then in the question, fewer number of 3 bags, fewer number of bags are underweight. So you can see that we are having a large number of the value, okay, of the n, and then fewer than the number, something happened to them. So for this kind of structure of the question, from here we know that it is belongs to binomial distributed. All right, where you can write it out like x is the number of bags of sugar that is underweight. So we are having it as binomial distributed. What is the n? So n will be a 10 here. And then what is the probability or the proportion of the bags which is underweight? So it will be 10%. When we write into the parameter, it should be a proportion which is 0.10. Okay, and to calculate the probability, they want us to get the probability that the number of bags fewer than 3. So I write x smaller, no, not included 3, smaller than 3. To calculate the probability for this one, we have to apply binomial distribution formula, where in general, when I'm having binomial distribution question, right, if let's say I'm having x equals to r, the general formula will be NCR p power r q power n minus r. This is a general formula for binomial distribution. And now if we want to apply in our question here, okay, x smaller than 3, that means that we can start from x equals to 0, x equals to 1, x equals to 2, not include the 3. So x equals to 0, x equals to 1, and x equals to 2. When x equals to 0, I'm having 10C0, then the p power 0, so 0.1 power 0, 0.9 power 10. Then when x equals to 1, I'm having 10C1, 0.1 power 1, 0.9 power 9, and also x equals to 2. So 0.1 power 2, 0.9 power 8. Okay, so we should stop here because they are not asking us to calculate the probability that include x equals to 3. Okay, so once we write out the formula in general, we can use calculator to help us and get the final answer for this part, where the value should be 0.930 correct to 3 significant figure. Right? Okay, so this is how we answer part A for this question. And let us proceed to part number B. For part number B, they are saying that the weight of the bags of sugar produced by company B are normally distributed. So please highlight the keyword normally distributed. The mean is given 1.04, standard deviation is 0.06 kilogram. Okay, so keyword here is normally distributed. So we know that later when we want to calculate the probability, we need to standardize it and find out the answer from the normal table. Okay, find the probability that a randomly chosen bag produced by company B weighs more than 1.11 kilogram. Okay, so for this question, since we know that x is normally distributed now, x means the weight of bags of sugar produced by company B. Okay, it is normally distributed where the mean is 1.04 and then the standard deviation is 0.06. So when we want to write in the parameter of the normal distribution, we should put it as variance. So 0.06 squared. Okay, then for this question, they want us to find the probability that the x weighs more than 1.11, so greater than 1.11. Okay, then this is the x, right? And it is normally distributed. Therefore, before we calculate the probability, we have to standardize it become z. So we are having z greater than value of x 1.11. The process of standardization is minus the mean, that means minus 1.04 divided by standard deviation. So I have to divide it by 0.06. Okay, get the value of z to 3 decimal places. So if you didn't do any careless mistake, it should be 1.167. To find the area of probability for z greater than 1.167, I have to take 1 minus value that I get from the normal distribution table. Okay, so 1.167. We'll scroll down here, 1.16. So 1.1, 6 is this one, and the 7 will be this value. That means you have to add 14 to the last two digits of 0.8770. Add 14 into the last two digits here. Okay, so if you add 14 to the last two digits here by right, you will get 0.8784. And the answer that we get for this question will be 76 over 625, or maybe correct to 3 significant figure, right? It should be 0.122. Okay, so this is the answer for part B. And now let us proceed to part number C. Okay, so for part number C, we are having 81% of the bags produced by company B weigh less than W kilogram. They want us to find the value of W. Okay, so for this question, if I try to translate the sentence into a simple form, 81% can be treated as a probability. So it will be 0.81. And the bags of sugar produced by company B weigh less than W. So when I want to write it out in the probability form, right, or the probability symbol, it will be P. Then the X, which is smaller than W kilogram, it will be equals to 0.81. Okay, and we are still having x as a normal distribution. Therefore, to calculate the probability, we should standardize it become z, where I will take the value of x, which is the w in this case, minus the mean. So the mean should be 1.04 divided by standard deviation, which is 0.06. And it is equals to 0.81. Right? And now, if we try to visualize it by using a normal distribution diagram, okay, it means that 0.81 refer to the area under the graph, okay, for the normal curve. So 0.81 is a big area, should be more than half. And then the sign here, z smaller than the particular value, is having the area 0.81, which means that this particular value should be on this side. So that when they are looking for the area smaller than this value, it refers to this whole area, and this whole area should be a large area, which is equals to 0.81. And our aim is to find out the value from the normal distribution table. Okay, so what should we look for? Okay, in the normal distribution table, we should look for 0.81 plus, but please take note that the 0.81 is the value of the probability, and we are looking for the value of z. Okay, so now let's have a look. 0.81, where's the probability, or where's the value that we can get here? Right, so let's have a look. To get the 0.81, it is the value of probability, and we should try to get it from maybe this side, inside. Okay, so the area, the value inside this area are all about the probability or the area. Okay, the value outside the table basically is the value for z. So we are looking for 0.81, which is the area value. So For 0.81, right, we have to look for the value smaller than 0.81 but closest to it. So I will have this value, this one, 0.8078. This value shows that it is closest to 0.81 and smaller than 0.81. And how can I make it become 0.81? I have to add 22 at the last two digits for this number to get 0.81, right? So the 22, we can look for the value at the back. So that means I can add 22 here to get the value. So to summarize the value of Z, we just need to read out the value. What do we have here is, if you read out from the value from the table, right, you have 0.87 followed by 8. So your value of Z will be 0.878. Okay, so we go back to our step here. This value of Z that we get just now is 0.878, which means that the phrase W minus 1.04 divided by 0.06, basically it is equals to 0.878. So we try to move everything to one side and we will get the value of W lah. So by right, originally the value of W should be 1.09268, and if we try to simplify it correct to 3 significant figure, then it will be 1.09. Okay, so this is how we answer question number 5. Question number 6. Okay, find the number of different arrangement, highlight the keyword arrangement. So the solution that we involve later, it will be about the permutation. So arrangement is a keyword for permutation. Your steps might involve n factorial or maybe NPR later. Okay, so we are having 9 letters here in the word activated. So usually for me, before I want to arrange all the letters, I will want to list out the possible letters that we have. Okay, so that we can see whether do we have any identical letters or not. So for this question, we are having 2A in the word activated. I'm having 2T, then I have 1C, 1I, 1V, 1E, and also 1D. There are 9 letters in total. Okay, so to arrange them without any restrictions, right? So we want to arrange 9 letters. Therefore, I will have 9 factorial. But out of the 9 letters here, we have identical letters, right? And we have 2 identical letter A. Therefore, in our calculation, I should divide it by 2 factorial. I have another identical T, 2 letter T. So I also need to divide it by 2 factorial. So 9 factorial divided by 2 and 2 factorial, I will get 90720 as the answer. So this is the arrangement without any restrictions. Okay, then we continue to part number B. For part number B, they also want us to find the number of different arrangement again for 9 letters in the word activated, in which there are at least 5 letters between the 2A. At least 5 letters between the 2 A's. Okay, so for this kind of question, maybe you have to try to list out the possible cases that we can have lah. So at least 5 letters between 2 A's. Let me try to illustrate it out. So let's say I'm having A here, and then must have at least 5 letters, 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the case where you have 5 letters between the 2 A's. Okay, but for this case, right, there are 5 letters between 2 A's. It can be also one other letter in front, then A at the second letter, then 1, 2, 3, 4, 5. It can be this case also. So this case also, I'm having 5 letters between the 2A. Or another case will be A at the last digit here, and then the first A will be somewhere here. So this is also another case where we have 5 letters between the 2A. Alright, so for some calculation, right, they will not list out everything here for you. They will straight away multiply everything with the 3 because the calculation is the same actually. Right. Okay, so now let's have a look. For this question, how can I calculate the permutation for this question? Okay, since we already put the A at a certain location already, at a certain position, so we are not going to arrange the A anymore. Okay, so for the first case here, I will only focus on the remaining letter. So I have 1, 2, 3, 4, 5, 6, 7. I'm having settled remaining letters here and I want to arrange them. So when I arrange the remaining 7 letters, the steps will be 7 factorial. And then out of the 7 letters, I'm having 2 identical t, right? So I have to divide it by 2 factorial. Identical t. Okay, I'm having 2 identical t's. Therefore, I have to divide it by 2 factorial. For this case, I no need to divide 2 factorial for the a. Why? Because I didn't arrange them. I just put them in a certain position. So I'm not arranging them randomly. I no need to divide it by 2 factorial because I fixed them at certain position already. Okay, all right. So this is the identity that we have, and after that I need to multiply it with 3. Why do I need to multiply with 3? This is the case where I show you just now, right? So first one, for the first case is 7 factorial divided by 2 factorial, and we are having 3 different cases where I'm having 5 letters between 2a. So I have to multiply it with 3 lah. Okay, so for the first case here, I'm getting the answer, which is 7560. Alright, so this is the case where we are having 5 letters between 2a. And according to the question, you can see that they are looking for at least 5 letters between 2a. So just now we list out the cases for 5 letters between 2a. Now we are going to list out 6 letters between 2a. So I'm having a, then 1, 2, 3, 4, 5, 6, then followed by the a, and lastly we are having 1 letter at the back. Okay, or it is also possible that we are not starting the arrangement by the A, but A is at the second position, then 1, 2, 3, 4, 5, 6, then A. Okay, so for case number 2, it is the cases where we are having 6 letters between the two A. To calculate the probability again, we are having the same idea where we want to arrange the remaining 7 letters, okay, in the space, so 7 factorial, but from the 7 letters, we are having 2 identical t also, so divided by 2 factorial. Okay, then for this case, 6 letters between 2a, right? You can see that we can list out 2 possible results for the position for a. Therefore, I have to multiply with 2. Therefore, for this question, I'm having the answer, which is 5040. Sorry, for this part, for the second case here, the answer that we get should be 5040. Okay, so is there any other possible result? We can still have 7 letters between 2a's, right? We can still make it as 7 letters between 2a. So the case will be a, and then 1, 2, 3, 4, 5, 6, 7, then a. So for this particular case, there's only one kind of position I can place the a. Okay, so I cannot like move them here and there anymore because it is fixed that a must be at the beginning and at the end, so that the total letters are 9 and 7 letters in between the a. Okay, so for this case, what I need to do is I have to arrange the 7 letters remaining, which is 7 factorial. Then out of the 7 letters, right, I also have the 2 identical t. Therefore, I divide it by 2 factorial. So from here, what do I get here is I get 2520. Okay, after I list out all the possible cases already, then I can get the total number of arrangement. So the total arrangement will be what? So the total arrangement will be adding up all the arrangement for the possible cases. And from here, you should get 15120. Okay, so this is how we try to arrange the letters according to the restriction given. Okay, then let's proceed to part C. Okay, so for part C, now we have 5 numbers or 5 letters are selected. So we want to select 5 letters from the 9 letters in the word again, activated. Okay, so again, what the question wants us to find is find the probability that the selection does not contain more T than S. The selection does not contain more T than A. Okay, so what am I going to do is I will try to find out the cases or the probability that they contain more t than a, then only I take 1 minus the answer for more t than a. Okay, so that I will get the probability of selection not contain more t than a. So now I focus on more t than a cases, more t's than a. Okay, it is worth to mention that when we are having the combination selected, the keyword selected here tell us about combination. We select, we choose, right? But for this question, they ask us to calculate the probability. Therefore, we have to consider all the possible identical letters in our calculation for the probability case. Okay, so for more t than a, first of all, I will want to consider the case number 1, where I'm having 1t, 0a. This is the case where I'm having more t than a, right? If I have 1t, 0a, that means that the case that I have is 1t, and then there's no a. When there's no a, right, the remaining 4 letter will be from the other letter lah. So just now we already list out, we are having 2a, 2t, 1c, 1i, 1v, 1e, 1d. Okay, t is already placed. T is already placed, right? So that means the remaining 4 I have to select it from C, I, V, E, D. Okay, and then for the t, because we are calculating probability for now, so to get the t, we have 2t, right? Therefore, from the 2t, I have to select one of them. So it should be 2c1. Then multiply with the remaining letter will be 5. 5. I don't want to include the a because we already stated we don't have a here. So I will select it from the remaining 5 letter here. So it will be 5. 5 letter I want to choose 4. So 5c4. So this is the number of selection when we are doing for more t than a, 1t, 0a. Then I need to get the probability, right? Therefore, I have to divide it by the total number of selection. So total number of selection means that I'm having 9c, 9 letter, and I want to choose 5 of them. So 9c5. Okay, then for the probability here, it should be 5 over 63. Okay, so for the question that involve combination, right? If let's say we include the probability in the calculation, please ensure that the identical letter, you need to consider the selection of it. So like for the t here, it will be 2c1. But if let's say the question is asking for number of selection, not the probability, then you will see that we will ignore the 2c1, we will not repeat the identical letter, but we only focus on the non-identical letter. Okay, so this is a maybe you have to take note about this part, the difference between the probability and also the number of selection. Okay, so the first case is I'm having 1t, 0a. So what are the other cases that have more t than a? Second case will be I'm having 2t and then 0a. This is also more t than a, right? If I have 2t, 0a, then that means I'm having 2t here and then 3 empty space. To calculate the probability, it will be 2c2, then multiply with 5c3. So again, the 3 letters here, I'm taking out from C, I, V, E, D only, not including the A. Divide by the total selection without restrictions, so it should be 9c5. Okay, so for this question also, I'm having 5 over 63. Then let's consider again, is there any other possible cases? Another case I have is maybe 2t with 1a lah. So this is also belongs to more t than a. Okay, so 2t with 1a, I will have being something like this, TTA and then other letters. Okay, so for 2t and 1a, the selection will be 2c2. The 2t I want to select all. For the a here, 2a I want to select only 1. And then the remaining letter, there are 5 letters, I want to select only 2. Okay, then divided by the grand total without the restriction, 9 letter, I want to choose 5 of them. And therefore, I'm having 10 over 63. Okay, then I think we already consider all the possible cases where we are having more t than a. Therefore, to calculate the probability requested in the question, we want to have not contain more t than a. I have to take 1 minus all the probability that I get here. And if I try to simplify this particular result or answer, right, it should be 43 over 63. Okay, so this is how we solve question number 6. Okay, so question number 7. Sam and Tom are playing a game which involved the bag containing 5 white discs and also 3 red discs. They take turns to remove one disc from the bag at random. These are removed, are not replaced into the bag. So the game ends as soon as one player has removed 2 red discs from the bag. That player wins the game. So as long as we get 2 red discs, then that player will be the winner. So Sam removed the first disc. Find the probability that Tom removed a red disc from his first turn. Okay, so for this one, basically you can see that Sam and Tom, they take one disc each other, like taking turns, right? So Sam will start the game first. Okay, for this question, if let's say if you want to visualize it clearer, you can try to draw the tree diagram. Where first one, I'm having the first person who take out the disc, right? The first disc is taken. It can be either white color or it can be either red color. And then for the first disc removed, right, it is actually removed by Sam. So maybe I can put a note here, this is by Sam. Alright, so first one, if you take out the first white disc, it will be 5 over 8 because originally you're having 5 white and also 3 red, right? So total there are 8 discs in total. So 5 the white number, there are 5 so it will be 5 over 8 to get the probability of getting the white will be 5 over 8. Then for the red one will be 3 over 8. After that, when the second disc is removed, it is actually by Tom. Again, I will also have white or red. Okay, so according to the first disc removed is white, right? So the second disc being removed is white. It will become 4 over 7. And this one will be 3 over 7. Then if let's say the first disc removed is red color, then the second disc removed is also red color, the probability will become 2 over 7. And then I'm having still 5 over 7 for the white. Okay, so we try to complete the tree diagram if let's say you need to visualize it in a clearer way. Okay, so maybe for the third one, if I try to list out again, then I'm having Sam. Okay, so I'm having white, red, white, red, white, red, and white, red. Okay, so first of all here, for this case, okay, I will have 3 over 6 now. And then this is also 3 over 6. For this one, okay, so what is the probability that I get? I take out one red, and also one white. So now to get the white again, it will become 4 over 6. And this will become 2 over 6. Okay, first one is red, second one is white, the third one is white again. Then it will basically become 4 over 6. And then 2 over 6. And the next one, if I get red, white, then the probability for white is 5 over 6. And then I'm having 1 over 6 here. Okay, and please take note that for this case, right, at this stage, it actually means that Sam win. Because the rules of the game basically mention that if any player get 2 red color discs already, then he will be the winner. So for this is Sam will be the winner if let's say he get the red at the second turn. Okay, at the second turn or the third disc removed. Alright, of course if you want you can still continue to draw the tree diagram further where the next turn will be top, but I feel that it is too many branches, like there are too many branches, so I don't really show up. Okay, so of course the game can continue until some of the player win. And please take note that we are only having 3 red discs in total. Alright, therefore need to consider very carefully when you want to include all the probability in the tree diagram here. Right? Okay, so let us have a look and see. Okay, they want us to find the probability that Tom removed a red disc on his first turn. So now, where is the Tom's first turn? This one. Okay, Tom's first turn is here, and he want to remove a red disc. So to remove a red disc, I'm having two possible pathway. This is the first one, as you can see, where Tom get the red disc. Another pathway will be the green color one, where Tom get the red disc. Okay, so to get the probability, I need to multiply them together and add each other. So I'm having Tom remove red disc on first turn. Okay, so the probability is the yellow pathway will be 5 over 8 multiplied with 3 over 7. Then the green pathway will be 3 over 8 over multiplied with 2 over 7. Okay, so from here, the total probability will be 3 over 8 if you want to see Tom remove the first red disc, which is red color. Okay, so this is how we get the answer. And let's continue further to part number B. Okay, so for part number B, they want us to find the probability that Tom wins the game on his second turn. So Tom wins at second turn. Right, so if I want to ensure that Tom wins at the second turn, right, basically we need to have a look for the outcome here. The tree diagram here might help us lah. Okay, so if let's say Tom win the game, that means Tom must get already 2 red discs. Okay, so to make sure that Tom get the 2 red discs, it need to be continued, where the first disc that Tom remove is also red, so that the second turn, okay, where Tom get the red disc, only he will win the game. Okay, understand what I said now? So that means maybe I need to further list out without writing out the probability. Okay, but I just show the result. Okay, so let's say Tom get the first red disc here. Okay, then where's the possibility that he get the second red disc? It will be somewhere here. Same thing happen. Okay, red and then white and red. Then the third case will be this one, where having W and R. So you can try to observe and see that if I want to get the probability for Tom win the game, right, he must have 2 red discs already, where the first pathway will be this one. Okay, so the first red disc that Tom get is here, second red disc Tom get is this one. Okay, after that we are having also this pathway, okay, where Tom get the first and the second disc, red disc. And again, we are looking for some other pathway. So the third pathway will be this one. Okay, Tom already get the first red, and after that follow this pathway, he get the second red. Alright, okay, so to calculate the probability, maybe I show the solution here so that we can refer to the tree diagram. Okay, so for part number B, if I want to get the answer where Tom win the game on second turn, okay, so follow the yellow color pathway. I'm having 5 over 8, then 3 over 7. The third one will be 4 over 6, where Sam get the white color one. And the last one is Tom get the red one. So if let's say Tom get the red one, right, it will be 2 over 5, because the remaining red color disc is 2. And then the remaining disc haven't removed is 5. So it will be 2 over 5 for the yellow color pathway. Okay, then plus, how about we have a look for the green color pathway? So for the green color pathway, if you have a look in detail, okay, so the first probability is also 5 over 8. Sam get the red one. Second, this remove is red color by Tom, so 3 over 7 also. Then according to green color, the third one is Sam remove the red color disc, which is 2 over 6. Okay, so I write clearer, this is a 2. And continue further, the next disk removed is red color by Tom, and the probability now will be 1 over 5 because we left only one red color disk at this stage here. Right, so this is the pathway, the probability for the pathway of green color. Okay, then for the blue color, if you have a look for detail, first one, red color disk is removed by Sam, so 3 over 8. Second, this is red color removed by Tom also, it will become 2 over 7. The third one is the white color removed by Sam, so 5 over 6. Then the last one here will be the red color removed by Tom, so it will be 1 over 5. This is the probability that we can get from the blue color pathway. Okay, so if you try to total up all the 3 steps here, the 3 total probability here, we will get 3 over 28 for this question. Okay, so this is the answer for part number B. Okay, so basically I still refer to the 3 diagram to help us or help me to visualize how to get the result that the question want. Okay, and let's continue to part number C. Okay, so for part C, what do we have here is they want us to find the probability that Sam remove a red color disk on his first turn given that Tom wins the game. Okay, on his second turn. Alright, so I think there's one important keyword here which is given that. Alright, so given that means that it is a conditional probability. So if I try to write out the conditional probability, usually it's like that. Find the probability that A given B. Okay, when they are saying that find the probability that A given B, right? The symbol for A given B will be A given B, and the probability will be A intersect B divided by the probability of B. Okay, so if I want to apply in our question here, given that Tom wins the game on his second round, so what I write is, I will write it like this, given that Tom wins at second round, at second turn. Okay, and they want us to find the probability that Sam remove red color on the first disk. Sam remove red. Okay, so maybe I write in other simpler way. I write Sam first disk remove is red color. Okay, so according to the definition for the conditional probability, right? So we're having A intersect B, where I should have Sam first color is red intersect with Tom win at second turn. Divided by the probability of Tom win at the second turn. Okay, so how can I find out Sam first color first remove this is red, and also Tom win at the second turn? So again, we can refer back to the tree diagram again. Okay, so like what I highlight just now, right? Or what the pathway that I highlight just now basically is the cases where Tom wins the game, right? So Tom wins the game. So we are looking for Tom wins the game at the same time. Okay, at the same time, Sam take out first color. First, this is the red color. So Sam first is red, intersect with Tom win at the second turn. So again, according to the yellow color, green color, and blue color pathway, right? Both all these 3 refer to Tom wins the game already, and now we are looking for another restriction where we want to see Sam get the first red color disc. So if let's say we are looking for Sam get the first red color intersect with Tom win the game, the blue color pathway is the only result that we are going to consider. Alright, so for the blue color result, you can see it is actually Tom wins the game, but at the same time also Sam get the first disc is red color. So I will include the blue color calculation, the probability in our calculation later. 3 over 8, 2 over 7, 5 over 6, and also 1 over 5. Okay, so let us put this into our calculation here. Okay, so the numerator on top, I will have the blue color pathway. So according to the blue color pathway, it should be 3 over 8, and then 2 over 7, 5 over 6, and then 1 over 5. After that, we want to find the probability that Tom win at the second game. So we already second turn, sorry. So you can see that we already get the answer for this part in part B. So the answer from part B is 3 over 28. Okay, so you just straight away put in the value here as the denominator value and simplify it by using calculator. You should have 1 over 6 as your answer. Okay, so for this question, to me, the way that can help us to visualize clearer will be actually the tree diagram. Although we need some time to draw it out, but it actually helps me to look very clearly what is going on. Alright, so this is already the last question for this paper. Thank you very much for watching the video.